So 1.3 is really just a review of solving all kinds of equations. So solving equations. And we're going to talk about a couple of things in this section. First, we're going to cover domain real quick. And then we'll review linear, quadratic, and rational equations. So that's kind of the outline for today. Okay, so let's start with domain. Oh, by the way, I didn't even see a sneak in here. This is Herman. He is a student currently at U of I. This is your sophomore year, right? Graduated here a couple of years ago. Hopefully we can get through this quickly, and then you guys can have a chance to work, and then him and I will both be helping with any questions that you guys have, okay? If you have any questions about college and stuff, you can ask him too, how that's going. So, all right, so anyway, domain. For you guys, probably the easiest thing that the easiest approach we're gonna take is assume that the domain is all real numbers. Unless you have one of two things for now. Eventually we'll add more to this, but unless you have a square root or a fraction, a rational function. All right, so those are the two things you have to be on the lookout for. Otherwise, just assume it's all real numbers. It'll just make more sense that way. Okay, and so with that being said, let's say we have an expression like the square root of 3x minus 5. And we want to know what the domain is. Okay, remember that domain is just allowable values for x. Okay? But a lot of times to find the allowable values for x, it's easier to determine what's not allowed. Okay, so depending on how you want to approach it, you have a couple different options. But probably the easiest is to think back to what you know about square roots. Okay? Are there certain numbers that you're not able to take the square root of? Start with that. Negatives. You guys know that already, right? So using that logic, so since you can't square root a negative, that forces whatever's on the inside of the square root to be greater or equal to 0. Did everybody buy that? Okay. If you can't have a negative in there, well, whatever this is has to be 0 or higher then if we're going to do anything with that. Okay? And so from here, you just solve for x. So add 5, divide by 3. You get that the domain is x is greater or equal to 5/3. Any questions on that? Okay, here's another example. Let's say we have 3x over x squared minus 9x plus 20. Okay, the reason we want to be careful with rational functions is because now we introduce division. Okay, and again, sometimes to find the domain, it's easier to think of rules that you've learned, like what are you not allowed to divide by? What is that? What can we never divide by? 0. Okay, can't divide by 0. So that means that this denominator cannot ever equal 0. Okay. Now, as far as solving this, like this was easy. We just added and divided. As far as solving this equation, we spend a whole couple of days reviewing factoring, right? You should be able to factor this quickly. How do I factor this? Okay. And so now once you have it factored, you set each factor equal to, well, not equal to 0. So x minus 5 cannot equal 0, x minus 4 cannot equal 0, and so therefore x cannot equal 5 or 4. And there's your domain. Okay? Any questions on that? So if I give you a couple more examples, let's see if you guys can find the domain real quick. If you're watching this video and taking notes, after we write down the problem, pause it, try it, then check your answers. All right, so here's 3 problems. Take a couple of minutes, try the domain, check with your groups, ask one of us for help if you're not sure how to proceed. Another minute? Okay, let's check how we did. For A, you take 11 minus 3x, make it greater or equal to 0, since that's how we start. Subtract 11, divide by negative 3. Whoops, that should be positive 11 thirds. So the domain is x is less than or equal to 11 thirds. Did we get that one? Okay. This one, factor. We're going to take the denominator, make it not equal to 0, factor either trial and error or the AC method. I will say something, though. This is kind of why I prefer trial and error. I saw a few people try the AC method and forget half of what comes after you figure out negative 12 is the number that you're looking at. Okay, if you factor by either method, and I can go over, let's see, that should be 4 here, 3 there, minus plus. Nope, that's not right at all. Plus 1. There we go. So that's 3x, that's negative 4x, and that works out. So that means x cannot equal 4 thirds or negative 1. Okay. Now, if you're doing the AC method, you do 3 times negative 4, which is negative 12, which I think some of you have written down, and then you use negative 4 and positive 3, but those aren't, see, that's what I started doing. Those are not the numbers that go in here. You have to split the middle term into negative 4x and positive 3x, and then group, right? And there's more steps that come after that. You guys know what I'm talking about? That trial and error makes sense? Okay, let's stick with that. Okay. C. Combine two of the things that we're looking at. First of all, x minus 2 has to be greater or equal to 0 because it's in a square root. So x has to be greater than or equal to 2. But what else is significant about this problem? Very good. So it's just x is greater than 2, okay? Can't equal 0, so that's why we get rid of the greater than or equal to. Just make it greater than. Make sense? Okay. If I gave you other problems, like x squared plus x, let's say, what would the domain be for this? All real numbers. Why? Yeah, we don't have a radical, we don't have a square or a fraction, so just assume it's going to be all real numbers if it's a normal polynomial or a linear or a quadratic or anything like that. Okay. Again, there are going to be more cases like when we start talking about logs and exponential functions, you know, things change there. But for now, we're only looking at linear, quadratics, and rational expressions. Okay. Questions? Cool. Then let's do solving equations now. And you know what? Like I said, this is review. So I'm going to actually put some examples up here, give you a few minutes to try them out within your groups there, and then we'll go over them. Let's try. Let's see. So here's a linear, about as complicated of a linear equation as we're going to deal with. So if you guys can get this, we're okay. All right, so try that one. And then let's set up 2 more. Actually, let's go ahead and put 4 up here. Why not? Actually, let's change that. Let's make it a little more interesting. All right, let's see what you guys can do with these. And again, if you're watching the video, pause it, try them all out first, then check when we go over. If you're stuck, let one of us know. All ready? Since it's not connected, like it's not behind that. You're trying to get next. Just don't bring it right now. Oh, you have? Say it again? Okay. I think it was just the first 1.2. We have 1.2 and then B4. B4 we went over, but we didn't collect it. Yep. And then we started at 1. Those are 2 B4s. We went over those. That's today's one. Okay, I'll change it. If you notice tomorrow that I forgot, just remind me. Sure.
You ever see that math equation that's going viral? What do you say? Wait. Yes. Would you get for that? What's this subtract? Yeah.
See if you can forward.
People we complain because they don't pay. Really? Yeah. They don't pay like the full month.
Follow, yeah, I would just worry about this stuff for now. There's a lot of stuff here. You can start within the brackets. Probably negative 4 combine my terms, and then you got a negative and negative square, whatever that is. And then it just becomes like something extra something. There.
I'm sorry for that.
You guys are looking pretty good so far. Center line.
No closer. Nah, dude. Maybe it's like one of those where you just plug it back in there. Oh, but
You're right. You can't factor. Cannot factor. All four of you, I'm sure you can piece
Do it out. I have do it out. I should have kept it.
Share the wealth. What is it?
Squares. 4AC. Minus.
We'll go another 3 minutes or so, and then I'll go through these.
Would you remember the song that you I don't want to get more space. These are when we were like 46. Oh, yeah.
Another minute.
How feet break apart.
All right. We're going to start going through these. Let's see how we did. All right. So first, this is just a linear equation. The goal is just to get x on one side. That's it. But there's a lot of stuff in the way. I would start with the brackets, follow order of operations. Can we do anything in here? I would distribute the negative 4 first. So that becomes negative 4x plus 20. I could even distribute on the other side, might as well. That's 13x minus 65. Okay. We can combine like terms in here. That's 22. And then now we can distribute the negative to this expression. So 3 minus 22 plus 4x. Combine like terms again, negative 19. Get x on the same side. This is not from here. It should be hopefully automatic for you, right? Over on this side, you get 9x if you subtract 4x. Does that make sense? And then I'm going to move the 65 over. That's going to be 46. Divide by 9, so your answer should be 46 over 9. How'd we do? Okay. That's about as hard as a linear equation as you're going to get. So if you can do that, you're going to be all right. This one. Again, I like to try trial and error, especially when there's not too many options to try. 3x and x would be the most logical choice for the beginning, right? To get 10, I can either do 1 and 10 or 2 and 5. If I put a 10 over here, that makes 30. That's not gonna help me. That's too large. So it's probably going to be 2 and 5. So let's see. Maybe put a 2 there, 5 there. Both of these have to be minused in order to be positive 10, right? And then you can check the outsides, multiply to negative 6. The insides, multiply to negative 5x. And so that's how you know you got the winning combo right there. You get negative 11x in the middle. Does that make sense? Now, you take each one, you set it equal to 0. So for the first answer, you get 5/3. For the second answer, you get 2. Okay, so whether you do trial and error or the AC method, here's where you should end up. Any questions so far? Okay, I heard some good discussion and pulling some information from old classes. What do we do if we cannot factor? Give up, is that what you guys said? Quadratic formula. Okay. Oh, were you looking at the last one? Oh. Well, we'll talk about the distance formula in this unit too. So maybe you're ahead of the game. That's what's going on. Okay. Quadratic formula. What is it? Yeah, sing the song if you don't remember it. Opposite of b plus or minus b squared minus 4ac all over 2a. Okay? Write it down if you don't remember it. You should know it. Okay? Once you have it all set to 0 like it is already here, you just plug everything in. So you're going to have opposite of b will be 3 plus or minus square the b value, that's a 9, minus 4 times a times c all over 2a. I'm going to go this way, sorry, I'm running out of space. There's really not much to do except here you get positive 4, combine that with 9. So you get root of 13, and then you get 2 in the denominator. So here are your solutions for the third one. Unless you use the distance formula, then you got something else. Okay. Any questions on these three? Okay. By the way, before we do this last one, I want to go back to these three problems. Okay, first one. If I asked you what the domain was, what would you say? Like just looking at this expression, right? What's the domain for x? Let me ask it this way. Do you see any fractions or square roots? So the domain is all real numbers, which means that there's no issues with domain. We don't have to worry about anything when we solve for it. We just solve it and we're done, okay? What about here? What's the domain? All real numbers. What about here? What's the domain? All real numbers. What about here? What's the issue with this one? Can't divide by 0 with these fractions. So here we know that x cannot be -5. What about here? X cannot equal 3. This we need to factor. It actually factors exactly to what these other two are. And so the domain for this expression is identical to what we have already. Okay? So it is helpful to know what the domain is before you solve. Okay? What this means then, you can solve this and see what happens. What you just have to be careful with is that you don't get any of these two values. Because if you get 3, for example, as one of the answers, or the answer, 3 is not possible in this expression. Does that make sense? So sometimes what's going to happen is you'll get multiple answers, and then maybe you toss one of them out because it doesn't work up in the original equation, or maybe they still both work, or everything works. Okay, let's just see what happens here. Now for this one, there's multiple ways to do this, but I think the easiest, since I don't like fractions, my goal is to always get rid of them if possible first. And I can do that by multiplying by this expression to everything. Since it's kind of like when we did those complex fractions way back in first semester, right? If we want to cancel all the denominators, you can multiply by x plus 5 and x minus 3 to cancel them all out. Okay? So now imagine you're multiplying every single fraction by these two factors here. Let's see what happens now. What happens with x plus 5 if I'm multiplying it with these two? Cancels out. What's left? X minus 3 times 1, which is x minus 3. Everybody okay with that first step? Okay? Now redo the problem. These two factors times this fraction. What's going to cancel? X minus 3 drops out. What's left? X plus 5 and the 2 in the numerator. And now, again, multiply these two factors to this third fraction. What's going to happen? Both of them cancel, so all that's left is 2x plus 2. We've turned something that looks probably a little terrifying into something that's not so bad. Okay, so let's solve. Distribute the 2. Combine like terms. Get x on one side, and maybe subtract the 12. So maybe minus x, and also subtract 12. You get negative 15 equals 3x. Divide by 3. So what's x going to be? Negative 5. But the domain tells us that we're not allowed to have x equal to negative 5. So this is one of those rare but important cases where there's no solution. Okay? Basically anytime there's issues with domain, you always want to check your answers at the end to see if they are legitimate. Okay? Make sense? Okay.